Nathan here with Renegade Solutions Company. I want to talk today about my tester, how I tested my product. To get something made, to get a product made right, it's actually very expensive. It's a lot more expensive than I thought it would be. So I really wanted to test this product out before I put a lot of money into it. A, and B, I really wanted to make sure it was going to work right. I wanted to make sure that it was going to work long term. I really wanted to do a torture test on it to make sure it was going to really hold up, because I can't really stand behind something that's not going to hold up really well. And I wanted to be excited about it, and I am. I really love how this turned out. So here's kind of the story. If you want to know more about the Nissan Rogue Heater boxes 2014 and 2020 that fail and are very expensive to fix, it applies to the Nissan Rogue Sports, all of them. I've got some other videos on that and more information there. This is kind of how I tested my product. It's a permanent repair for these. It's way cheaper than trying to get it fixed at the dealer, and it's permanent. So this is the part that's failed. I have videos on this. And my first idea was this. Basically, I plastic welded one of these together. This is a 3D printed one just for a mock-up, but I plastic welded one of these together, ran it for 9 months, and I actually had, this came from the design files that were going to be injection molded. But after 9 months, I took it apart. It was not working. The plastic just does not hold up to any kind of abrasion. Unless there's something permanently bonded to it, it does not work. And I had to scrap that idea. That was a little hard to do because I put so much money into it. But it led to my second idea, which was this. It's a two-piece design. There's this insert that fits in here. There's a collar, and the collar will hold this together. It also keeps it centered. So if this is egged out really bad, you can still put it in centered and everything will line up. The gear, the teeth are the same. I copied Nissan. They did a good job on the gear parts. Changed the shaft. I've got this star shape, Torx kind of looking shaft on here that would engage and turn the blend door. Seems like a great idea, but I agonized over it because I didn't really have a way to test this. There's 3D printed parts, but they don't hold up. I mean, I put these in my tester and they just snap. So that was the first problem. The second problem was this is not really injection moldable with precision, at least the shaft part, because the shaft is much thicker than the rest of the gear and everything. It's not thick enough to have a vent hole in it. A lot of times, cavities, vent holes, and whatnot on injection molded parts are there simply for cooling and to keep it so the plastic's not so thick. If there's a part of a component that has a thicker section of plastic, it's going to cool differently and warp coming out of the mold, and it's not going to work. So we played around with trying to set up the mold to make this a little different shape, so when it did warp coming out, it would still work. But I didn't want to spend all that money to get a prototype that's actually injection molded and then test it. Or I looked at getting one of these machined on a CNC. It was still very expensive. So I was grappling with that, but that's where we were headed. And my design guy said, hey, it's too bad we couldn't just put the male end on here and then have the other end here. And I thought, well, we can, there's room. And why didn't I think of that earlier? I'm not a design guy and whatnot. So I was really glad that he came up with that, but at the same time, I had to throw away another idea. And I put, I don't know, money into this. I mean, it was a lot of money to me. But I knew that the other way it was just going to be so much better. And I knew I would have a way to test it. I just knew in my mind that I could figure it out. And so I did. I came up, this is just a nylon standout for electrical. I use it on electrical boxes and sometimes on computers and whatnot. Took one of these, cut it down, and there's always a taper. So all of these taper a little bit because of the mold. The mold has to be able to release, right? So it can't be a straight part. It has to kind of taper down. So I cut it, shaved it down, tapered it, made it fit, on and on. So I had this half. So I actually took one of these doors, I glued one of these in with my bonding system and made it permanent. And then the gear, had a little bit of trouble with. This is the factory gear right here, this shaft right here. Had to go from that to an end that would fit on here. And I went to a machine shop. A guy was super nice to try and help me out. He tried to help me, but his equipment was just way too big and he couldn't drill it down and make it work very well. So I was kind of stuck on my own, and I really needed to test this. So I know I got help from above. I mean, I believe in God, and I know He helped me because this is what I came up with, and it's every time I look at this, I get goosebumps because I mean, I made this. I mean, I didn't make this. I did. I was the person with the hands, but I really got inspiration and a lot of help. I mean, it's beautiful. So I have this insert piece here. It was a part of a different component. I cut it down. I was able to get it in a drill and machine it down to this size. I was able to take 2 of these gears and just using a drill press. Basically, I used a drill press, an angle grinder, and a Dremel, and a bench grinder to come up with this. I mean, it was pretty miraculous. So that's pretty awesome. I mean, it even looks really good. And it fits on here. So then I have the 2 pieces. And that is what I have over here. This is my test box right here. I had that set up on here, and I ran it 10,000 cycles back and forth, and I'll show you how it works in a minute. Pulled it apart, and it was beautiful. Not a scratch, no looseness, no wear, anything. It was just beautiful. So I knew I had the idea. I knew that it would work. And so I went ahead, spent the real money to get it injection molded. And then once I got my first prototypes back that were actually injection molded out of the real nylon 6/6, then I put it in the tester and ran it again. So I have this. These are not just a DC motor. These are a brushless motor. So I have my friend Peter. He owns a computer shop in Rexburg. I put this together for me. It's a controller, so I don't know if you can see it here. I'll show you on the test box, but you can run forward, backward. Then there's an automatic function. It's really cool. So hit that. It'll go one way for 13 seconds, or 12, whatever it is. It'll go the other way for the 12 seconds or whatever. And that's how I tested it. So I made this test box. I'm not known for making things pretty. I'm known for making things work and work well, but not really pretty. So this is what I got. Took a heater box. I took out all the non-essential components, and I have one of those blend doors in there. I don't know if you can see it in there very well. Got my motor here. This has got my kit, my final product in there. And then I've got a counter on top. So I just went to Walmart and got one of these clip counters. I screwed a little washer to the top, and then I took some of this just plumbing pipe, plastic plumbing pipe, and I rigged this up. And each one of these tally marks is 1,000 cycles. So I ended up running this thing back and forth. I'll show you how it works. And plug it in. Look at this door. I'll put it on automatic. Here, you can see it's just running. There we go. It stopped against the one side. Then it goes the other direction. So it goes full stop to full stop. So then it runs this little arm and it clicks my counter. Well, it did. The counter actually finally broke. It just flops around. It doesn't do anything anymore. It was actually more than 171,000 cycles, but that's all I could count because it kept going and the counter had quit. So anyway, I had this going, it was 5 or 6 weeks. I check it every day and reset the counter and put marks on it. And it would just go back and forth and back and forth. And that's how I got 171,000 cycles out of this thing. I pulled it apart. In fact, I'll just pull it apart right now and show you what I got. So there's that. That's the insert piece that glues in. So that's permanently on there. It's a permanent part of that. And then here's the gear part. It's inside this, the actuator. And it is tight. Yeah. I mean, it's nice and tight. The gear slides on tight. I mean, I have to use a little bit of force. There is no wear on that. It's awesome. And I didn't expect any wear. I mean, it's only 10 inch-pounds of torque. So it's really not a lot of pressure. It's just the design of the door in there. So that's how I got that. I figure, depending on how much you drive your car, could be 50 years or more of driving your car every single day. It doesn't just run back and forth when you turn on the heater and try and go from hot to cold and switch the temperature. every time you drive your car, it's going back and forth at least once to determine where the hot side is, where the cold side is, so it can know where it's at. Why it does that, don't know, but that's what it does. And anyhow, that's how I tested it. This is my heater box and kind of how I got here, and hope that answers some of your questions, and hope you have a great day.